Hey everyone, my name is Noah and I'm a 3D printing and laser cutting instructor at the Digital Arts Experience. I love to make stuff. It's always cool, doesn't always work, but it's always a good time. This will be the first installment of what we're calling the Noah Builds a 3D Printer series. Name pending, because that's not that great. And I'm going to be, in this episode, taking you through my process up until this point where we are right now. Because I've been working on this project for a really long time, and I think it would be pretty cool to bring it to all of you guys. The first thing that I think it's important for us to talk about is why I decided to build a 3D printer, because they're pretty readily available online, and the prices have been coming down substantially. So why would I go out and say I want to build a 3D printer using an entirely custom design that I create? And really the inspiration behind that was I wanted to take on a pretty hard challenge, because sure, I could design this thing or that thing in Tinkercad or Fusion 360, but I wanted to take on something really, really hard. So I said, okay, I'm going to custom design a 3D printer by myself with no external help. So that's what I did. I started in Fusion 360 and really just began with the frame and kind of filled in all the components as it became necessary. Some basics about the printer that I decided to build. I wanted a pretty large build volume because I had bought a 3D printer before starting the project, but its build plate was about 6 inches by 6 inches, so pretty small, and the materials available to use with that printer were really limited. I had to use the filament that company provided, and I couldn't really control any of the settings, so I wanted to completely design and be able to control every aspect of this machine, and that began with the original tech specs, which I decided I wanted it to be big, accurate, and very versatile in terms of filament and any other user settings you could want to use. So that led me to settle on a box style 3D printer, which basically means it's a box, pretty self-explanatory, with a build plate of 1 foot by 1 foot. So build plate itself is 4 times larger than the one I'm used to, and the build volume is, if I'm doing the math right, 8 times larger. I also wanted to make sure there was a heated bed, because that impacts what types of material you can use with the printer. Now moving on to the belt style, or the kinematic style. As I said, it's a box frame, which means that the extruder head, which is what puts out the plastic, is going to move in the X and Y directions. So that's like if you're in math class and you're graphing something, you have your X-axis and you have your Y-axis. So it's a 2D plane. That's where the extruder moves. And then the build plate will move in the Z direction, which is up and down. And each of those types of motion is controlled by different systems in the printer. So I had to obviously design and model and then put them onto the frame. So let's start with the Z, because that's kind of the simplest one. The Z axis is controlled by a screw. As the screw turns, the build plate is moved up and down by it's kind of a nut, but not really, on the screw. The screw is turned by a motor, which is controlled by a control board, which really allows the printer to function. We're actually not up to wiring the thing yet, but when we do, we'll bring all that coverage to you. Now the X and Y axes are controlled by also motors, but motors that are driving timing belts instead of a screw. And in a box frame 3D printer, there are a lot of different belt styles that you can use. One belt style has one motor controlling the X-axis and one motor controlling the Y-axis independently. But I decided that I was going to use something called Core XY, which is where both motors control both the X and the Y axes. And it's kind of hard to explain, but I'm going to show you a diagram that will demonstrate it a little more clearly. Basically, the benefit of a Core XY system is, if you think about it, when you're printing something, most of what you're doing is straight lines, either forward and back or side to side. And what Core XY does is it makes those key movements controlled by both motors. So it allows those movements to be a lot faster because both motors are acting on them at the same time. Versus in a more standard system where one motor controls X and one motor controls Y, only one motor is acting when the print head is moving on those very standard directions. So that's the benefit. It's a bit of a complicated way to run the timing belts, but we figured it out eventually. Unlike my original printer, this one has a glass print surface, which means that the bottom of the prints is going to be a lot smoother and they're going to stick down a lot better while it's printing. You're not going to get any of those warping effects or print failures due to sliding, which you can get on a metal non-heated print bed or one that you cover with tape. I also had to design a system that would allow me to level the print bed, and that's really important because as the print head moves along, if the print surface is not level, then the distance between the nozzle and the print surface can change, which will affect how well the filament is able to stick down. So that's simply controlled by some screws with springs on them. So as you tighten the screw, the bed moves down. As you loosen the screw, the bed moves up. And that allows you to change the location of 4 different points on the bed. The printer itself has at least 30 custom designed parts that I have modeled myself over the last few years to make it function. The parts that I needed to order were really limited to the metal and electronic components. So in terms of metal, I needed to order the aluminum extrusion pieces that I used for the frame, any screws or bolts. The X, Y, and Z axes are guided by steel rods that bearings run along. So that allows for smooth and controlled and stable motion. So obviously I needed to order those because they needed to be really, really precisely machined, which is what I did. And all of the belt pulleys and things like that, the smaller bits, are all metal and ordered. And as for electronics, the glass print surface and the heat bed, the extruder, any cooling fans, and most importantly, the control board, which really coordinates this whole thing. It's the brains of the operation. That was, of course, ordered online, as well as the power supplies, which are what convert the power that we get from the wall to work with the control board and, as a result, the printer itself. In terms of the parts that I designed, we have the extruder mount, we have the pulley mounts for the X and Y axes that control where the belts run. We have all the mounting brackets for the rods that control the X, Y, and Z motion. We have the motor mounts for all of the specific motion components. We have mounts that attach the print bed to the Z rods that control its movement up and down. We have some bracket pieces on the control box, and we'll even have some laser cut pieces on the control box. The control box itself is a box made out of 1/8 inch acrylic, laser cut, with black on the sides and back, and then we have clear on top and on the front so that you can kind of see what's going on inside. Electronics right now are pretty minimal. Very little wiring has been done. I have wired the 12-volt power supply, and as a result I have a cooling fan inside of the control box that is supposed to keep everything cool once it's running, but obviously it's not running yet, so just the fan works. And we also have some pretty cool lights on the outside, because why not? And as you see, it even turns on. Pretty cool. That's all we got though. And once that turns off, the control box is also designed to be easily modified once it's all put together. So with that in mind, these clear pieces can slide out, and then you get easy access to the inside. So pretty cool. Let me just get this back in. Coming up, we really only have a few things left to do. We need to mount the end stop switches, or the limit switches, to each of the 3 axes. Those are what allow the printer to home in to a origin point or a 000 location before beginning any printing operation, and that's what prevents it from crashing into the sides. It knows exactly where it is because of those limit switches, so we need to mount those. And then all that's left after that is a lot of wiring and some firmware configuration. So we're going to bring you along for the ride, but we're nearly there, so it's a very exciting time to be documenting this and jumping on and getting started. So I hope you have enjoyed learning about all this. Please like and subscribe to the Digital Arts Experience YouTube channel. We have a lot of cool content coming out, and hopefully this has brightened your day in a pretty difficult time. So thank you, and see you next time.